Okay. Good morning to all of you students. Please wait, I will share the screen. Students, during last lecture, we discussed about the scheduling algorithms. Okay. What is scheduling algorithm? Why it is needed? When more number of processes are there to use the CPU, operating system, inside the operating system, there is a segment of the program which will have algorithm.
Hello, ma'am.
That is called a scheduler. That is called a scheduler. Okay. So that scheduler will decide that which process will be using the CPU. Okay. So we are currently discussing about those algorithms only. Already students don't confuse, already one set of algorithms we saw. Those algorithms are IPC, inter-process communication, mutual exclusion algorithms. Inter-process communication, mutual exclusion algorithms. Okay, don't confuse those algorithms with this algorithm, scheduling algorithm. Okay, so you should understand what is the use of the scheduling algorithm, when exactly it will be used. Okay, in a ready queue, that means in ready state, always there will be more than one number of processes in multi-processing system. Okay. So when more number of processes are there in ready queue, when the ongoing process exited, operating system should decide that which process from the ready queue will go to CPU. Okay. So especially here, there is a part of the operating system code which is called the scheduler. The scheduler will have all these algorithms, whatever we are discussing as scheduling algorithms. No, all these algorithms will be a part of the scheduler segment of operating system. You should understand this first. Okay. During last lecture, we discussed about the Fcfs scheduling algorithm. That algorithm is non-preemptive algorithm. That means once a process started to use, any of the process started to use the CPU, in between, before completing its execution, the process cannot be evicted from the CPU. Okay. So once process started, it cannot be evicted. That is why it is called a non-preemptive. Once process entered inside the CPU, in between the execution, the process cannot be taken out from the processor. Okay. So that is called a preemptive algorithm. Okay. Non-preemptive algorithm. Preemptive is vice versa of this. During the execution of a process, before completing its execution, process can be evicted from the CPU. That is called a preemptive. Okay. So Fcfs is non-preemptive algorithm. Understood what is non-preemptive? During the execution of the process, in between process cannot be evicted. That is called a non-preemptive algorithm. Okay. There are so many algorithms, students, but in your syllabus, as per your syllabus, they have given few algorithms which are very most commonly used. Okay. So this algorithm already we discussed, first come, first served. In this algorithm, how the process were selected from the ready queue based on its arrival time. Based on process arrival time, the scheduler will select the process from the ready queue, okay, to use the CPU. Okay, so Fcfs algorithm is based on the process, different process arrival time. First come, first served. So you can easily remember by seeing this name itself. Okay, which process arrived first or earliest, that process will get the chance to use the CPU at earlier. Okay, the process which arrived into the ready queue earlier, that process will get to use the CPU, get chance to use the CPU earlier. Okay. So based on the arrival time, the scheduling happened. Okay. I hope you remember what is burst time. Burst time is nothing but CPU time. Okay. Every process, how much time in form of milliseconds it wants to use the CPU. That is called a burst time. CPU time of each process is, CPU execution time of each process is called a burst time. Okay. Completion time, by looking into this Gantt chart, Gantt chart, you can easily say the completion time. Process B0, 2 is completion time. Process P1, 8 is completion time. Process P2, 12 is completion time. Process P3, 21 millisecond is a completion time. Process P4, 33 millisecond is a completion time. That is given here. After you calculated the completion time, you will calculate turnaround time, because turnaround time is required to calculate waiting time. Remember, process ID, arrival time, and burst time will be given. Okay, will be given in the examination if we ask to calculate the waiting time. Okay, suppose theory questions comes, explain any 2 algorithms, scheduling algorithms, then you have to pick up some examples like this. Sorry, and you have to randomly take the process time, arrival time, and burst time. Always arrival time take sequentially. Okay. It is not necessary that the gap between the arrival time should be 1. Here I have taken 1. It could be 2, 3 also. And it is not required the gap should be taken uniformly also. For example, first process might have arrived 0th millisecond. Second process might have arrived 1 millisecond. Third process might have arrived 3 milliseconds. That means, 4 milliseconds. So gap between this two is 1 millisecond. Gap between this two would be 2 milliseconds. Like that also you can take the values. I repeat again. I may ask you by giving the process ID, arrival time, and burst time in the examination. And I may ask you to calculate the average waiting time. Of course, to calculate the average waiting time, you have to calculate the waiting time of each and every process, isn't it? Okay. So that can be one type of question, which will be 5 marks question, descriptive type. That time about this scheduling algorithm, you no need to write theoretically anything. If I ask a problem by giving this 3 process ID, arrival time, and burst time, if I ask to find the average waiting time, that time theoretically you no need to write anything. But I may ask you to explain any one of the algorithms. Okay, any one of the scheduling algorithms theoretically, then you should choose example like this, and you have to derive and show everything: completion time, turnaround time, and waiting time. And you should calculate, you should draw the Gantt chart also. Okay. Theoretically, if I ask, you can write, you have to start with what is scheduler. What is scheduler in operating system? Scheduler is a code segment in an operating system, which will have the mnemonics of what? Mnemonics of the scheduling algorithm. So what is scheduler? Scheduler is again software. It is a program. Okay, part of the system program. Operating system is a system program. No, it's not a user program, right? It's not an application program. It's a system program. So the scheduler is a part of the system program. Okay. Then what it will do? It will have the scheduling algorithm. It will have, scheduler will have scheduling algorithm. Okay. So that you will write first theoretically what is scheduler. And then about the preemptive and non-preemptive. About the preemptive and non-preemptive algorithm. And then you have to say about what is Fcfs. Remember? First scheduler, then about preemptive, non-preemptive algorithm, and then which algorithm has been asked. For example, I asked FCFS, or otherwise I asked the other algorithms, SJF, shortest job first. So about that algorithm, you have to write what is that algorithm, and then you have to give the example like this, and you have to calculate the waiting time, average waiting time, and show. Getting it? Or I may ask, I may explain FCFS by giving the name of the particular scheduling algorithm, or otherwise I can say any one of the algorithm. Then that is your choice. Okay. That time also you have to write all the theory, and then you have to find your own value for this to find the waiting time, average waiting time by following that algorithm, and you have to derive completely all these things you have to do and show. Remember, write and keep in a descriptive type questions in your semester question paper. Descriptive type questions may definitely I will ask any one of the scheduling algorithm. No other way this should be asked. Okay, in operating system, scheduling algorithm should be asked. If it is there in the syllabus, it should be asked any one of the questions related to scheduling algorithm in descriptive type. Remember, okay. So one question is confirmed question I have given to you. Remember. So this is about the FCFS. Okay, we will just speed up. Okay, completion time. By seeing the Gantt chart, you will calculate. You will just put, I can say, so not calculate. And then turnaround time. Turnaround time is nothing but completion time minus arrival time. When the process completed, so completion time minus arrival time. Okay, that is turnaround time. And then waiting time, you calculated. I did not activate any action, but it is asking 1 second. Retry. Okay. So turnaround time, you will calculate completion time minus arrival time. Okay. I should not click because when I'm moving the cursor, no, then it is getting automatically it is getting selected. Okay, that's why the pop-up came. Okay. So then waiting time, you calculated the turnaround time. So turnaround time minus burst time will be the waiting time. Okay, completion time you're calculating because you have to calculate turnaround time. Turnaround time you're calculating because you have to calculate the waiting time. So our ultimate aim is what? To calculate the waiting time. To calculate the waiting time, you need what? Turnaround time. Burst time is already there. But to find the turnaround time, you need completion time. Okay, that's it. So this is the first algorithm. Average waiting time you calculated. This should be the ultimate output. Okay, which you have to show. Average waiting time. Once you calculate the waiting time for all the processes, you will add that sum of the waiting time of all the processes divided by number of processes. Okay, you should be careful when you see the number of processes because it is sometimes it will start from 0, sometimes it will start from 1. Okay, so that if it starts from 0, by seeing this you should not put the number. Okay, that mistake commonly students will do. That's why I'm saying. Okay, everything they might have completed correctly, but here by seeing this, they will put what? 4. Okay, so that mistake you should not do. Is this clear, students? Students, is this clear?
Yes.
Okay. So next, in this slide, even this also we discussed. Okay. What is the disadvantage of FCFS? Because nowadays no scheduler is having FCFS. Maybe FCFS will be some scheduler of the operating system will have combination of algorithms to schedule the process. Combination of algorithm. It is not necessary only one algorithm should be followed. It can combine more than one algorithm and it has to schedule the process. Scheduling the process means what? Taking the process from the ready queue and put it in a CPU. That is called scheduling. Okay. So that now only whenever the scheduler is using combination of algorithms, that time this would have been used, FCFS. But nowadays, none of the scheduler is having FCFS as a single algorithm to decide the scheduling. Okay, remember, because it has strong disadvantage. Limitation is there. That is called starvation. The disadvantage is called starvation. It is termed as starvation. And it is also called as convoy. It will create a negative effect. That effect is called a convoy effect. Okay, so remember. And what is the disadvantage? Look at this diagram, Gantt chart. Simply we have taken three programs, three processes. First process, CPU burst time, look at here, 40 milliseconds. 40 milliseconds is a process P1, CPU burst time. Okay. Process P2, 3 milliseconds, 43 minus 40. Okay. And process 3's CPU burst time is just 1 millisecond. Okay. But just because of the process P1 arrived earlier in the ready queue, just because of process P1 arrived to ready queue earlier, the process P1 will start to use the CPU. Okay. But its CPU burst time is very long, 40 milliseconds. Okay. And process P2 and process P3 arrived in, for example, process P1 assume arrived in 0th millisecond. Process P2 arrived in 1 millisecond and process P3 arrived in 2 milliseconds. That means immediately after the process, excuse me, immediately after process P1, process P2 and process P3 are arrived. But still, this process P2 and P3 should wait 40 milliseconds. 40 milliseconds process P2 and P3 should wait. Though these processes CPU burst time is very less. This has to use only 3 milliseconds CPU. This though P3 should use only 1 milliseconds. P3 wants to use only 1 millisecond CPU. But still see the waiting time. How much time P3 should wait. That is P3, how much time it waited. That is depending on when it arrived, no? Okay. Suppose assume that in 1 millisecond it arrived. Then 42 milliseconds it should wait. Okay. So this effect is called convoy effect. This leads to starvation of shortest job. Shortest job is nothing but a process. Okay. So shortest processes, if they arrived a little later, they have to wait longer time if the previous processes CPU burst time is long. This is called starvation. To whom starvation will happen in FCFS? Only the processes who arrived later with the very shortest CPU burst time. Okay, that will only suffer because of the starvation issue. Okay, is this clear? Okay, next algorithm is called shortest job first algorithm. Okay, expansion of this I did not write because it is there in your textbook. Okay, I always want to put very less content in PPT, but that is the good procedure to create PPT also. Okay, so SJF what that and all definition of this processes algorithm and all I did not put in the PPT. Okay, because it is there in your textbook. Okay. So categories of scheduling algorithm. Next algorithm is SJF. That is also non-preemptive algorithm. That means what is non-preemptive? Once the process started to use the CPU in between the execution, it will not be evicted. Process will not be evicted in between the execution. That is called a non-preemptive. That is called a non-preemptive type of scheduling. So FCFS also in this type non-preemptive cannot be evicted in between. And SJF, shortest job first also cannot be evicted. Okay, so that is also under non-preemptive scheduling algorithm. Okay, We have taken some processes P1, P2, P3, P4, P5. These are process ID. Okay, we have to identify processes, no? And arrival time you see 1 millisecond, 3 milliseconds, 6 and 7, 9 milliseconds. These are arrival time of 5 different processes. And CPU burst time is given. Okay, all these three, completion time, turnaround time, waiting time, usually you have to calculate. Okay. But before calculating this three, the next step by seeing this, you have to draw the Gantt chart. Okay, that will be helpful to understand the scheduling pattern of this complete multi-processing system. Okay. So here, no process arrived in 0th millisecond. Observe, no process arrived in 0th millisecond. But you have to start with the 0th millisecond. So 0 to 1 millisecond, none of the processes were there in the ready queue. Okay. Because in 1 millisecond only, which process 1 is arriving in the ready queue. Okay. Its CPU burst time is 7 millisecond. Okay. So first in 1 millisecond, when only one process is there in the ready queue, we cannot apply any algorithm. Okay, because no other option, only one process is there, that should be scheduled, right? Isn't it? So in 1 millisecond, as only one process is there in the ready queue, our scheduler will schedule this process. Okay. So process P1 starts first. Okay. So when it is started, it will start just based on the arrival time, based on FCFS only. Okay. After more process comes only, we can apply the shortest job first algorithm, because shortest job first means shortest process should be executed first. That means first preference should be given to the shortest process. What is shortest process? The process which is having the smaller CPU burst time. CPU burst time is called shortest job. Job is nothing but process. Remember, here they are saying shortest job and longest job. All those are depending on its CPU burst time. Okay. So shortest job first means shortest process first. The process which is having very less CPU burst time should be given preference first. Okay. So that is shortest job first algorithm. What was the previous algorithm? Which process will be given the priority? The process which arrived first will be given the high priority in FCFS. But here it is depending on the burst time. Why? Why? To overcome the disadvantage of what? Starvation and convoy effect. Okay. Let the process, initial process, the process which are having the shortest CPU burst time get chance to use the CPU by taking high priority. Okay. So in the 1 millisecond only process P1 arrived. Its CPU burst time is 7 millisecond. Okay. So process P1 started in 1 millisecond. Why 1? Because it is arriving and 0. It is arriving in 1 millisecond only. Okay. So P1 started. It is non-preemptive, isn't it? It is non-preemptive. So once process P1 entered, it will not be evicted. It has to completely complete its 7 millisecond CPU burst time. Okay. So when it will be entered, when it will complete its CPU execution in 8th millisecond, it will complete. Which one? Process P1. Okay. Because its CPU burst time is 7 millisecond. Okay. Then now how much time got completed? 8 millisecond. Please listen, this is very important. 8 millisecond got completed, right? In this particular multi-processing system, how many milliseconds completed? 8 milliseconds completed. Look at the arrival time. In 8 milliseconds, which are the processes must have arrived in the ready queue? Which are the processes will be available in the ready queue? Process P1, process P2, process P3, process P4. But not process P5. Why? Because it will be arrived only in 9th millisecond. But we have completed 8 milliseconds only till now. Okay. When 8 milliseconds completed, only these processes, process 1 to 4 only will be there in the ready queue. All these processes are now in the ready queue. Now there are more number of processes. We have to apply the SJF algorithm. Okay. So when we apply the SJF algorithm, of course, process P1 completed its execution. So we have to just delete that. This will not be included now currently because this process P1 will not be there in the ready queue. Right or not? Students? Now process P1 completed the execution, right? Process P1 completed the execution. When it will complete in 8th millisecond, it will complete. Okay. By the time except process 5, all the other process must have arrived in the ready queue. But in process 1 to 4, already we completed the execution of process P1. Now to apply the SJF algorithm, we have to consider only process P2, P3 and P4. P2, P3, this is process ID. Okay, this is what I'm saying. Process P2, which has burst time 3, and process P3, which has CPU burst time 2 milliseconds. Process P4, which has CPU burst time 10 milliseconds. Only these 3 processes are available in the ready queue right now. Right now, matlab what? When 8 milliseconds got completed, only these processes will be there in the ready queue. Okay. Now we are applying the algorithm. Among these 3 processes, which has shortest CPU burst time, process P3 has shortest CPU burst time because its burst time is 2 milliseconds. Other 2 processes, CPU burst times are 3 millisecond and 10 millisecond respectively. Okay. So by applying the shortest job first, we have not the scheduler had chosen which process to this process P3, which has the CPU burst time 2. Okay. So next, after the process P1, P3 enters. Okay. P3 now entering inside the CPU. What is the CPU burst time of process P3? 2 milliseconds only. Okay. Which category of algorithm is SJF? Non-preemptive. So it will not be in 8th millisecond P3 entered inside the CPU. So it has to complete its 2 millisecond execution. Then only it will be evicted. Why? Because it is a non-preemptive algorithm. Okay. So when it will complete its execution, P3, when it will complete its execution in 10th millisecond, because 8 plus 2, 10. Why 2? Here its CPU burst time is 2 milliseconds. Okay. So in 10th millisecond, process P3 must have completed its execution. Okay. So now how many milliseconds got over? 10 milliseconds when P3 completing its execution in 10th millisecond. So after started this particular processing, how much time got over? 10 milliseconds. Okay. Look at the last arrival time of the process, 9 milliseconds. So now all the processes are there, including process 5 is also there in the ready queue. Okay. But which are the processes which are the processes currently will not be there in the ready queue because of it completed its execution? Process P1 completed the execution. Process P3 completed the execution. Okay. Now, which are the processes we have to consider to apply SJF? Which are the processes excluding process P1 and P3? We have process P2, process P4, process P5. Okay. Process P2 we have, process P4 we have, process P5 we have. Okay. Now on these 3 processes, the SJF algorithm will be applied. Okay. Which process will be selected? Process P2 will be selected. Why? Among these 3 processes, this, and this, which has shortest CPU burst time. Process P2 has shortest CPU burst time. Okay. So this will be selected next. Look at here. Look at the Gantt chart. P2 enters next. Okay. What is the CPU burst time of P2? 3 milliseconds. What does the algorithm says? It is non-preemptive. So P2 enters in 10th millisecond and it will complete its execution complete execution in 13th millisecond. Okay. Now P2 also completed its execution. Now, as per this given values, no other new process arrived, isn't it? So now which are the processors are there without, that means in the ready queue to use the CPU? Only P4 and P5, because these all the three processors completed the execution of the CPU, execution inside the CPU. Okay. Now only these two processes are there. No other new process arrived. Okay. So which process will be selected by seeing this, by taking this algorithm SJF? Process P5. Process P5 entered in the 13th millisecond. It will complete its execution in 21st millisecond. And then we have only one option in a ready queue to put it in a CPU. That is what? Process P4. Then process P4 will go to the CPU in 21 millisecond, and then it will complete its complete execution in 31st millisecond it will complete. Okay. So this way the scheduling will happen. Okay. Now after you have drawn complete Gantt chart, you have to yet to complete the calculation of completion time, turnaround time, and waiting time, isn't it? Okay. How will you calculate the completion time? Just by seeing the Gantt chart itself, you can put the completion time. Okay. P1, 8 milliseconds. P2, write sequentially always. Okay. Don't go according to the scheduling sequence. Okay. When you calculate the completion time. P1, 8 milliseconds. P2, 13 millisecond. Okay. P3, 10 millisecond. P3, 10 millisecond. Completion time. Okay. P4, 31 milliseconds. P4, 31 millisecond is the completion time. Okay. And then P5, 21 milliseconds. P5, 21 milliseconds. What is the turnaround time? How will you calculate turnaround time? Completion time minus arrival time. 7, 13 minus 3, 10, 10 minus 6, 4, 31 minus 7, 24, 21 minus 9, 12. So these are the turnaround time. Okay. Turnaround time and waiting time, just a formula I have given in this. I did not repeat in every slide. Turnaround time equal to completion time minus arrival time. Waiting time equal to turnaround time minus burst time. This once in this slide I have given. So when you refer, you can refer that. Okay. So calculated the turnaround time. Now we have to calculate the waiting time. To calculate the waiting time, we will need what? Turnaround time. So what is waiting time? Turnaround time minus burst time. Okay. 7 minus 7, 0. 10 minus 3, 7. 4 minus 2, 2. 24 minus 10, 14. 12 minus 8, 4. So we completed waiting time of each process. Now you have to add all these waiting time. You have to find the sum of the waiting time of all the processes. Okay. Divided by what? How many number of processes are there? 5 processes, because process ID is starting from 1, no? 1, 2, 3, 4, 5. 5 processes. So sum of the waiting time divided by number of processes. Here it is 5. Okay. You will get average waiting time. You will get average waiting time. One thing you have to remember, you should not leave like this. Here I did not calculate the average waiting time. Okay. But your final, the end of this question answer should be what? Average waiting time. You have to end with the average waiting time. Remember. Okay, always if it is asked in the question or not asked. Okay, because the efficiency of the algorithm. The efficiency of the algorithm. That means after I taught all algorithms, I'm asking which algorithm is the best algorithm. How can you say? The deciding factor of the good algorithm is average waiting time only. Process should not wait a long time, unnecessarily occupying main memory. That should be our aim in the scheduling, during the scheduling. Okay. So waiting time should be reduced. See, if you see every algorithms which were invented, which were introduced or suggested or proposed in a different period of time to just reduce the waiting time of the previous existing algorithm. Suppose now you are in your PhD, okay, you're finding some new algorithm, okay. How can you justify that algorithm is a good algorithm, best algorithm than other algorithms? When you find a new algorithm itself, your motto should be reducing the waiting time when comparing with all other existing algorithms. Remember, okay? So that is one thing. But that time when you compare the waiting time of all algorithms, please listen, students, this is very important. How can you compare the waiting time, average waiting time of all the algorithms? For that, you have to take all these three columns same to apply all algorithms. ऐसे नहीं है now like me. Previous में these are different values, these three values. But either I have taken different values. It should not be like that. When you compare the algorithms, these three values, same value you have to take. And for the same value, you have to apply the FCFS first and you will find the average wait time. And then you will apply for the same value SJF and then you will find out the average wait time. Okay, waiting time. And even other algorithms also. Then only you can compare which algorithm is the best algorithm. Okay, is this clear, students? Students, could you follow? Am I going very fast? What, Sweetie, you said something, no? Sweetie?
Yes, ma'am, we can follow.
Others, you, Sweetie, you're attending lectures regularly, operating system lectures?
Yeah, ma'am, I attended regularly.
Sorry?
I attended regularly.
1 or 2 days you were not there, ऐसे है क्या?
Yes, ma'am, the previous lecture I didn't attend. It was at 8.
Okay.
So watch the video of that.
Okay. See, video will be helpful when, suppose now today your lecture is very lengthy lectures. Your schedule is morning 8:30 to 6 o'clock. But now normally 6 o'clock exactly, whenever my practical is there, I will just try to complete 5:30 itself. Okay. So 6 o'clock. So it's a lengthy duration or schedule, no. So that time you can see, you can just you can bunk 1 or 2 theory lectures, underline, not practical, theory lectures. Even if you feel very difficult to attend or concentrate, you no need to attend. The recording will be there. You can watch recording. Okay. But when you are having very comfortable schedule, that day you have to try to attend all the lectures because simultaneously you're losing your attendance. Okay, whenever you're not attending the lectures. Then that will lead to again defaulters, then so many things you have to do. Usually for the defaulters, every month we will calculate defaulters list and then some assignment or some even presentation will be given only to those defaulters. They have to, the separate presentation meeting will be scheduled, topic will be given, they have to present that. Okay, like that and all we did, but now because of time, we couldn't do anything. But anyway, attendance will be taken. attendance will be considered, because minimum this much percentage attendance should be there to give you a semester exam. That is there. Okay, that we have to follow. If rule protocol is like that, we have to follow. Remember. Okay, but we will not inform each and every hour, 1 month once or 15 days once, this is your attendance, you're lacking in attendance and all. Okay, we will not say. Just before giving the hall ticket, that should be cleared. Okay, so we will calculate everything and then we will give the report. If your attendance is low, then they will what? You have to go and meet the principal or say Pura. Okay. So you just don't put into you in that issues. Okay. So attend the lecture as much as possible. But if continuous lecture is there, of course, that you have to take care of your health also. So that time you can what? The recording will be for my lecture. I will record lectures only, not practical. Lecture I will record it. You can watch. Okay. Okay, but this is not, again, this is for now just a time being only. Once offline completely full-fledgedly started, then recording वगैरह कुछ नहीं है, you have to directly attend the lecture. Okay. Mostly today Monday, Tuesday, tomorrow 8 to 1, 8 o'clock to morning, 8 o'clock to 1 o'clock there is a room, but that only the room number 32, the room in which you couldn't sit. Okay. So I think MP lecture, offline lecture would be there tomorrow. Ma'am will inform you, but tentatively it is decided 11 to 1. So 11 to 1 you will have offline lectures. Okay. But 8 o'clock onwards it is free, room is free, but no teachers are free. We have TY exams and SY practical exams. Okay. So afternoon till 1 o'clock you will attend the microprocessor lecture tomorrow, only tomorrow. I am talking about only tomorrow. Because we couldn't put the schedule for 1 week. Okay, why? Because availability of rooms are what? Decided just previous day, like that. Okay, so that is the issue. So tomorrow, till now we decided 11 to 1 MP lectures, offline lecture will be there in the college. And then you will go to your home and 3:30. So 1 to 3:30, you can travel. Wherever you have to go, you can go to the respective place. And then 3:30 to 6, definitely lecture or practical will be there. Okay. This is tomorrow. Day after tomorrow, I will be able to say tomorrow only. Okay.
Okay, ma'am.
Okay.
Ma'am, before the lecture, you have called me.
Yes, to ask this only, your attendance only.
Okay, ma'am.
I suddenly felt that you, whenever you attend the lecture, you will interact, no? So last lecture and all, I taught algorithm, but you did not ask. Usually you will ask questions. You did not, so I thought, okay. I just wanted to know why you did not attend the lecture. That's it. Okay, because in your class, very few students are interacting. Kaifali, are you there? Kaifali, he did not attend. Pages. Apurva is there. Himakshi is there. Okay. Ayo. Chalo. So SJF is over, completed. Okay. Next algorithm is shortest remaining time first algorithm. Shortest remaining, SRTF, it is not shortest job first algorithm. Okay, this is shortest remaining time first, shortest remaining time first algorithm. Okay. Okay. So next algorithm is Srtf algorithm, which is shortest shortest remaining time first algorithm. Okay, what is remaining time? We will see because this is a preemptive algorithm. Preemptive means what? During the in between the execution of the process, the process can be evicted. Okay. Can be evicted from the CPU, but the evicted process will be kept inside the ready queue only. Remember, the evicted process will be kept inside the ready queue. Then only later it will go to, whenever its turn comes, it will go to again to use the CPU. Okay. Students, in my voice or sound, may any differences there? Just 5 minutes before and now, because I changed the place.
No, ma'am.
No.
No, ma'am, it's
Both the
okay.
places are okay. Matlab, okay. Same clarity, no? Okay. Now, this is a preemptive algorithm. This is the first point you have to remember. Okay. So now we will see why here remaining time. This is remaining burst time, CPU burst time. Remaining CPU burst time. Why remaining? Because one process is executed, in between it is evicted. Then of course its execution time will change, no? For example, one process CPU burst time is 5 milliseconds, assume, when it's entered in the ready queue. Please, you have to concentrate, you have to listen keenly. Okay. Assume one process entering inside the ready queue with 5 milliseconds as the CPU burst time. Okay. Once it got chance to use the CPU, okay. But when it is executing inside the CPU, after completing 3 milliseconds, it got evicted. It is possible because it is preemptive. Okay. So the 5 milliseconds when it completed, after completing 3 milliseconds, it got evicted. Now, what is the CPU burst time of that process? It will not be 5, it will be 2, right? Isn't it? How 2? Because total CPU burst time of that particular process is 5 milliseconds. It executed, it's completed its execution 3 milliseconds. So see, remaining what? 5 minus 3, 2 milliseconds will be its CPU burst time. So the CPU burst time will change. Okay. So we can't say that as a shortest time, burst time. We have to keep some other name for that. That is, we kept a remaining time. So after executed, remaining how much CPU burst time is there, that is called a remaining time. Okay. So shortest remaining time first. Shortest remaining time first. This algorithm itself preemptive only. This cannot be converted to non-preemptive. Okay, because it is remaining time. Okay. Now consider the processes. Process ID 1 to 6, arrival time sequentially 0 to 5. Burst time, there are various burst time. CPU burst time of all the 6 processes have been given here. Okay. We have to, this is the preemptive algorithm. So you may feel little confused, but as much as possible, I will make you to understand, but you have to listen. That is very important. You have to listen to understand. Okay. Okay. First, in 0th millisecond, which process is there in a ready queue? Because processes are arriving one after another. Not all the processes are available at the same time, right? So in 0th millisecond, only one process is available in the ready queue. So scheduler will schedule only that process, no other way, right? So in 0th millisecond, only process P1 was available. Its CPU burst time is 8 milliseconds. Okay. So process P1 enters inside the CPU. It started 0th millisecond. Okay. Its execution time is what? 8 milliseconds. But it completes 1 millisecond. When it completes 1 millisecond, 0 to 1. Okay. When it's complete 1 millisecond, once a millisecond got over. Okay. At that time, assume that process P2 arrived. Of course, process P2 arrived in 1 millisecond. So when the process P1 is in half of the execution, not half of the execution, it completed only 1 millisecond from 8 millisecond. In 8 millisecond, it completed only 1 millisecond. Exactly that time process 2 arrived. Okay. What is the CPU burst time of process P2? 4 milliseconds. 4 milliseconds is a CPU burst time of process P2. Now currently, what is the CPU burst time of process P1? In 8 milliseconds, it completed 1 millisecond. 0 to 1, 1 millisecond completed. So what is the remaining burst time of this? 7 milliseconds. So now which are the processes are currently available? Process P1 on execution, but we have to include that also because it is preemptive algorithm. Okay. Now currently in 1 millisecond, there are 2 processes only. One process has 7 milliseconds as a CPU burst time. How 7? Because its actual CPU burst time was 8 millisecond. In that it executed 1 millisecond. So P1 ka CPU, remaining CPU burst time. P1 already started execution, no? So it is called, should not be called burst time. Remaining CPU burst time is 7 milliseconds. That's what in notes I have written. 7 milliseconds. Okay. Now, which are the processes are there? Process P1 and P2. P1 has 7 milliseconds burst time. P2 has 4 milliseconds burst time. What is the algorithm? Shortest remaining time first, and also preemptive, allowed to take out at any point of time if high priority job comes. Here, what is high priority? Because algorithm is shortest job, shortest remaining time. That means the algorithm works again based on the burst time only. Okay. So in this in 1 millisecond, there are 2 processes. One is having 7 as CPU burst time, another has 4 as a CPU burst time. Okay. Now, which process should go to the execution? The process which has shortest time, shortest burst time. Okay. So process P2 will be given chance. Process P2. Process P1 evicted after completing only 1 millisecond. Still, it has 7 milliseconds to use the CPU, but it is evicted. How? Because the algorithm is preemptive algorithm. In every millisecond, it has to wait the CPU. It has to check this CPU burst time of all the available processes. And at that point of time, which process is having shortest remaining time, CPU burst time, remaining time, that process will get chance to use the CPU. Okay. So when comparing with the process P1 and the process P2, process P1 has 7 milliseconds CPU burst time, process P2 has 4 milliseconds. So comparing with these two in 1 millisecond, when comparing with these two values, the process P2 should get chance according to this algorithm. So P2 will enter, okay. Remember P1's CPU burst time is 7, remember, okay. Now P2 enters. What is the CPU burst time of P2? 4. In that, P2 executed 1 millisecond. 1 millisecond, because I said in after every millisecond you have to check. Okay. So after completing 2 milliseconds, totally how many how much milliseconds got over? 2 milliseconds. Okay. When 2 milliseconds get over, which are the processes are there? Which are the processes are there? First 3 processes. Okay. But the third process which arrived recently has the CPU burst time 2, which is less than the previous 2 processes. Okay. Processes P1 ka arrival time currently 7 milliseconds. Process P2 in its 4 milliseconds, it completed the execution of 1 millisecond. So its remaining burst time is what? 3 milliseconds. So that I have written here P2 3. Okay. Now which is a new process arrived? P3. P3 arrived newly. Its CPU burst time is 2 milliseconds. Now you compare 7, 3, 2, which is the shortest remaining time? Process P3. Process P3 has shortest remaining. So process P2 will be evicted. Okay. And P3 will get chance. P3 will get chance. Okay. Now P3 started execution when it's arrived at 2 milliseconds and it started its execution in 2nd millisecond itself. Okay. What is the CPU burst time of P3? CPU burst time of P3 is just 2 milliseconds. Okay. So when P3 completes its 1 millisecond, I said after every millisecond you have to check. Okay. Now P3 completing 1 millisecond. So 1 more millisecond is there for P3. Okay. Now when it completed in 3rd millisecond, it completed P3 completed its 1 millisecond. P3 completed its only 1 millisecond when the multiprocessing system completes 3 milliseconds. Okay. So 3 milliseconds which are the processes are there? These processes are available. All these processes are available. In this, which is the shortest time, remaining time? Please be careful. Listen here. P3 completed 1 millisecond. Okay. Its actual execution time is 2 milliseconds. So remaining time is what? 1 millisecond. Okay. So P1 7 milliseconds. P2 3 milliseconds. P3 1 millisecond. Newly arrived process P4 is also 1 millisecond. Okay. But if tie happens like this, tie happens like this, the scheduler will apply another algorithm. That algorithm could be, mostly that algorithm will be Fcfs. Okay. So in between these two processes, this now currently it's CPU burst time. Remaining CPU burst time is what? Process P3, 1. Newly arrived process CPU burst time also 1. Okay. The remaining 2 I did not consider because those 2 are more than 1. No, this is 7, this is 3. Okay. But tie is between what? Process P3 and P4. Okay. Now CPU should, sorry, the scheduler should decide which process in between these two should be selected. Now which algorithm we are in? Shortest remaining time. It will apply another algorithm which is shortest job first, sorry, first come first served algorithm. Okay, depending on the arrival time. In between these two processes, which arrived first? This process P3, which is currently on execution. So this will be given the priority. So P3 continues, P3 only continues the execution. Okay. So now P3 in this point, P3 when 4 milliseconds completed, it completely completed its execution. 2 to 4 it got executed. How it completely completed its execution? Because its CPU burst time is only 2 milliseconds, right? So it completed the execution. Okay. When it completed, anybody asked anything?
Yes, ma'am. Which completed its burst time, P3 or P2?
P3. Because P3's burst time is 2 milliseconds. No, already started to execute 1 millisecond here. Okay, then comparison between all the available processes. In that process P3 and process P2, sorry, process P3 and process P4, both has the CPU burst time 1, 1. There is a tie. Okay. So now between this, which process the scheduler will select? By applying SRJF only, this tie happen. Both the processes are having same CPU burst time. Okay. See, don't confuse. You don't think that, ma'am, here it is 2. How you are saying both are same?
Yes, ma'am.
Anybody is
That
having that
one
doubt?
is the remaining time, no?
Sorry?
That P3 is remaining time is 1 only, no?
Kajal, you did. This is what I asked. You did not listen before. See, P3, I am talking about this point, students. P3 completed 1 millisecond. P3 completed 1 millisecond. Remaining 1 millisecond only, no? P3 is a CPU remaining burst time is 1 millisecond only now. Here I written, here I did not write, but I said, okay. Now
Yes,
P3,
ma'am. I understood.
sorry?
Yes, ma'am. I understood.
Remaining. That's why you underline this remaining burst time. Okay. So in 3 milliseconds, third millisecond, which are the processors are available? In third millisecond, may only process P3. These 3 processors are available. Okay. In 3 milliseconds, when it complete 3 milliseconds, even the process number 4 arrived newly. Okay. Now, how many processes are there in the system when 3 milliseconds completed? Process P1, process P2, process P3, process P4. Okay. Among this, which is the shortest remaining burst time, which has, this also has 1. In third millisecond, it completed 1 milliseconds. Okay. So this also has, process P3 has remaining burst time 1 millisecond. Process P4 has remaining burst time 1 millisecond. Okay. So there is a tie. Okay. Now the scheduler will apply another algorithm, which is Fcfs algorithm, to choose the process between these two. Okay. Why? Because these two are having 1 millisecond as a CPU burst time, and which is shortest available, shortest remaining burst time also. Okay. So when between these two processes, when we apply Fcfs, which will be chosen? Only the process P3 will be selected. Because P3 arrived before P4. Fcfs will give preference based on the arrival time. Okay. So now process P3 selected again. Of course, it is already there in the CPU, so it will continue the execution. That's why 2 times P3 I put here. Listen. Okay. So 2 milliseconds to 4 milliseconds, who will be executed in the CPU, inside the CPU? Process P3. So process P3 CPU burst time is 2, totally 2 only. No, it completed. Look at here, 2 to 4, 2 milliseconds got completed. So process P3 at first it is completing its execution in this multiprocessing system. That's what here I highlighted. Which are the processes completed the execution I highlighted. So P3 completed the execution because its remaining time, execution time, CPU burst time became 0. That means it completed the execution. P3 completed the execution. Okay. When it completes the execution in 4th millisecond, it is completing the execution. Okay. Now look at in 4 milliseconds, how many processes were there in the queue, ready queue? Except the last process. Except the last process, all other processes are there. All other processes are there. Remember, in this all other processes, which processes got completed the execution? Process P3 completed the execution. So you should not include that now when you apply the SR shortest remaining time first algorithm. Okay. Now except the last process, all other processes are there. Okay. In that, this is got over. This process completed the execution. We have to compare the CPU burst times of different processes, which are burst times are 7, 3. Look at here, 7, 3, 7, 3. This is completed. Okay, this is 1, and this is 3. Right? All these processes are currently in the ready queue. Why not this? Because this is entering in 5th millisecond only. Now we are talking about only the 4th millisecond. Okay. So all these processes are there now. In this, which process will be selected by applying this algorithm? Which process? Any one of you? Now which process will be selected?
P4.
P4.
Good, P4. Because among the all processes, P4 has the shortest burst time. Okay. So now P4 will enter. P4 to only 1 millisecond its CPU burst time. So it will complete its execution. So P4 equal to 0. P4 also completed. P4 why quickly completed? Because its CPU burst time is only 1 millisecond. Okay. P4 completed in 5th millisecond. So by the time when P4 completes its execution, all the processes are there. Okay. But remember, P4 and P3 completed the execution. These two will not be there in the ready queue only. Why it has to wait to ready queue? Because the processes which are waiting to use the CPU only should wait. No. These two processes though already used the CPU. So these two processes deleted. Will not be there. Deleted will not be there in the ready queue. But remember, these two will be there in the disk. In a virtual memory, this two will be there. Okay, but now it is not required. You don't confuse. Okay, so that I am saying it, we cannot say it is deleted. Okay, these two completed. Okay, now we have to complete 1, 2, 3, 4. These 4 CPU burst. But process P1 and P2 already sometimes it executed CPU, no? So its remaining burst time is what? 7. P1 ka remaining burst time 7. P2's remaining CPU burst time is 3. It's not 4, 3. So 7, 3, 3, 2. 7, 3, 3, 2. Which is shortest one? Which is shortest one? Process P6. Process P6. Okay. Because process P1 CPU burst time, remaining CPU burst time 7. Process P2 remaining CPU burst time 3. This is got over. This also got over. And this is as it is. Because these two processes arrived newly, did not even use the CPU once. Okay. So this is as it is, 3, 2. And this is 7, 3. 7, 3, 3, 2. Which will be selected? process P6 because this only now has the shortest burst time. Okay. Now process P6 enters at 5 milliseconds. Okay, and 5th millisecond, the process P6 will enter. Its CPU burst time is what? CPU burst time 2 milliseconds. Now 1 millisecond may we no need to see. Why? Because all the processes arrived, no? All the processes arrived. Okay. So process P6 selected its CPU burst time 2 milliseconds. It started the execution 5 milliseconds. 5 plus 2, it will complete its execution in 7 milliseconds. Okay. So P6 completely completed the execution. P6 completely completed the execution. Okay. So we should not include now this also in the algorithm to apply the algorithm. Okay. Now which are the processes are there? 1, 2, process 1, process 2 and process 5. Process 1 to 5 are remaining. Okay. Now process 1 to 5 may, which is the shortest CPU burst time. Remember here it is 7, here it is 3. It's written here. Okay. So 7, 3, 3. Again tie. Again tie. Okay. But when tie happens, which algorithm will be applied? Any one of you? Which algorithm will be applied?
Fcfs.
Fcfs will be applied. So as per the Fcfs, which will be selected? P2. P2 should be selected. Okay. So P2 remaining time, CPU remaining time is what? 3. Okay. So next P2 will enter in the 7th millisecond. Of course, each and every milliseconds may we no need to stop and compare because now all the processes are right. Okay. So P2, how many milliseconds remaining? 3 milliseconds. So 7 milliseconds may it will start and 10th millisecond it will complete the execution completely. Okay. So now P2 also moved. It will not be there in the ready queue. Now which are the processes are there? We have 2 processes, which is P5 and P1. P1 and P5. Okay. P1 7 milliseconds. P1 7 milliseconds CPU burst time currently. And P5 3 milliseconds, of course. P3 will be selected. Wrong diagram. P5, correct. So P5 will be selected. So after P3, P5 will enter. Okay. P5 will enter when in 10th millisecond. For P5, this is a first chance, right? So it will complete its execution. P5 3 milliseconds is the CPU burst time. So 10 milliseconds to 13 milliseconds it will be executed. It will use the CPU. And then after it completely completed its execution, it will be evicted. It will come out of the ready queue. Then we have no option, only one process. Only one process. That process is P1, which has the CPU burst time 7 milliseconds. Remaining CPU burst time 7 milliseconds. So 13 milliseconds say 20 milliseconds it will be executed. Okay. So this way the execution will happen in a preemptive Srtf algorithm. Shortest remaining time. Shortest remaining time first. Okay. Shortest remaining time first algorithm. Okay. Now Gantt chart is ready. Gantt chart is ready. Okay. We have to find out the completion time. Completion time, process P1. Process P1 20 milliseconds. Process P1 20. See, last occurrence of P1 you have to see. First occurrence is P1 here. Second occurrence is here. So which is the last occurrence? This. Because here it did not complete its execution. No, it completed the execution actually here. P1. Okay. So completion time P20, P1. P2's completion time 10. Okay. P3's completion time 4. Okay. P4's completion time 5. Okay. P6 completion time P6. P5 I said no. P5 completion time 13. P6 completion time 7. So completion time calculator, turnaround time is nothing but a completion time minus arrival time. Okay, 20 minus 0, 20, 10 minus 1, 9, 4 minus 2, 2, 5 minus 3, 2, 13 minus 4, 9, 7 minus 5, 2. Okay, turnaround time equal to completion time minus arrival time, calculate. Then waiting time is nothing but turnaround time minus burst time, right? Turnaround time minus burst time. Okay, 20 minus 8, 12, 9 minus 4, 5, 2 minus 2, 0, 2 minus 1, 1, 9 minus 3, 6, 2 minus 2, 0. Okay, this response time is actually not required, because to calculate the waiting time we don't it is not required. Okay, but here it is given. 1 second. Response time T0, 0 second. Okay, E1, process starting in P1, P1 0 millisecond. P2 1 millisecond. P3 P2 arrived at 2 millisecond. How much time it is responded? 1 second. Now process P1, no. Process P1 arrived in 0th millisecond. Okay. Okay. Process P1 arrived in 0th millisecond, but when it got chance to use the CPU in 0th millisecond itself. Okay. So response time is 0 milliseconds. Okay. Response time is 0 milliseconds. Again, I repeat, process P1 arrived at 0 millisecond. When it started, underline, started to use the CPU, started to use the CPU in 0th millisecond itself. So its response time is what? 0 millisecond only. Okay, when it's arrived, immediately it enter inside the CPU. That's why here 0. Process P1 arrived in 1 millisecond. Process P2 arrived in 1 millisecond. When it got first chance to use the CPU in 1 millisecond. Right. Process P2 arrived in 1 millisecond. Process P2 arrived in 1 millisecond, but the execution started. They have given when the multiprocessing execution started. But execution started in 0th millisecond. So its response time, here they are considering this entire system as a single multiprocessing system. Okay. So this is a multiprocessing system ka 0th second. So 0th millisecond. This is multiprocessing system ka 1st millisecond. Okay. So as per that, process P2 enter in 1 millisecond. Okay. it got chance to use the CPU after completing 1 millisecond of the multiprocessing system. That's why 1 is its response time. Okay. Let me see other processes also, then it will be clear. Okay. Process P3 entered in 2 milliseconds. Process P3 entered in 2 milliseconds. When it got chance to use the CPU in 2 milliseconds. Okay. Instead of comparing with the arrival time, just by seeing the Gantt chart itself, you can say it, students, what is the response time? It is like first when the process got chance to use the CPU. Okay. Process P1, 0th millisecond, first it got a chance to use the CPU. Process P2, 1 millisecond, it got chance to use the CPU. Process P3, first occurrence you have to see here. Okay. Process P3, second millisecond may it got chance to use the CPU at first time. Okay. So 2 here. And the process P4, in 4th millisecond, first time it started to use the CPU, first time. Okay. So 4th millisecond. Process P5, it started to use the CPU in 10th millisecond. Okay. Process P6, it started to use the CPU in 5th millisecond. Okay, this is response time. Okay, because why this is extra given here? Because it is preemptive algorithm. It's preemptive algorithm. Completion time will say the second occurrence of the process. For example, process 1 ka first occurrence this, second occurrence is this. But completion time is not 1 millisecond. Second occurrence ka completion time this. So completion time in preemptive, it will consider the second occurrence. We can't say second occurrence. That is depending on the last. It will consider only the last occurrence. Okay, completion time. Okay, nothing is here. None of the value shows the first occurrence, no. So that response time is added in a preemptive algorithm. So by seeing the Gantt chart itself, you can say the response time. Okay. When the process first started to use the CPU. So first matlab what first occurrence only you have to compare. You have to see. So this is P1 ka first occurrence. This is P1 ka second occurrence. But to find the response time, we have to see the first occurrence only. Because first when the process got chance to use the CPU. 0th millisecond. Process P2, 1 millisecond. Process P3, 2 millisecond. Process P4, 4 milliseconds. Process P5, 10th millisecond. Process P6, 5th millisecond. This is clear? Okay, usually we will not calculate, but they have given. Okay, this response time. This is clear, students, or anything else you want to ask, students?
No, ma'am, it's clear.
Okay. So now I will be giving a break. Okay, next we will see the round robin algorithm. That's the next algorithm. This is called the round robin. Okay, round robin algorithm. This is the one more algorithm we have to see, scheduling algorithm. And after this, we are completing the complete process management. Then we have to see the memory management. We will discuss about the memory management after completing the round robin algorithm. Okay. Now 58, 10:10 exactly. 10:10 you will join. Okay. Till 10:10 there is a break. Thank you, students.